All right, everybody, welcome. Let's see, is my mic working? My mic is working good. Got a student request to take a look at number 13. It gives you this little equation. It says 5x cubed plus 40 equals the integral from c to x of f of t dt. First, find f of x. Okay. Well, we can do this. Okay. I guess first what I will do is, I'll just write the problem down. So 5x cubed plus 40, let me turn the ink flow up there. 5x cubed plus 40 equals integral from c to x f of t dt. C to x f of t dt. What is f of x? Okay. This comes down again to the fundamental theorem. Okay, so before we get directly into the problem, let me write this down. Fundamental theorem is d by dx of integral u to v f of t dt. And if we do this derivative, what we're going to get is f with v plugged in times the derivative of v minus f with u plugged in, and then times the derivative of u. And so if I apply d by dx to both sides of the yellow equation, that's what I'm going to do next. I'm going to do d by dx of the left-hand side. And if I do d by dx of the left-hand side, I have to do d by dx of the right-hand side. Okay? And now on the right-hand side, well, let's do the left-hand side first. Left-hand side is actually easier. The derivative of 5x cubed, that's just going to be 15x squared plus 0. So we get 15x squared equals, and then this. We know what this is. This is going to be, just plug in from here. So my top limit is x, so I'm going to have f of x multiplied by the derivative of x. Derivative of x is 1. Minus f at c multiplied by the derivative of c. Derivative of c is 0. Okay? So we get 15x squared equals f of x. Okay? So now we're just kind of, from here, we're just going to kind of reverse engineer the problem. So we found f of x. That part's done. So we're going to look back at the problem now, and what's it asking for? It's asking for c, okay? And we know that c is inside this integral. So literally, I'm just going to reverse engineer the problem. I'm just going to write the problem down again, okay? So if I write the problem down again, I'm going to write the left-hand side first. I'm going to write the right-hand side first. Integral c to x. F of t dt equals 5x cubed plus 40. Okay, well, if f of x is 15x squared, then that implies directly that f of t, just replace x with t, is going to be 15t squared. Okay, so we have this then. We have the integral from c to x of 15t squared. And we know what the result has to be. The result has to be this. So let's keep that in mind. But I'm just going to work with this directly. If I integrate 15t squared, I'm going to get 15 t cubed over 3. let's see, and then we're going to evaluate. That's the antiderivative, and then we're going to evaluate from c to x. So 15 x cubed over 3 minus 15 c cubed over 3. And we know, well, first let me just do some algebra. So 15 divided by 3 is 5. So we get 5x cubed. And then minus 5c cubed. So 5x cubed minus 5c cubed. And we know that that result has to be the following. So here's the result. Okay, what I'm saying is this. This has to be the same as this. Okay, so we get 5x cubed plus 40 has to be the same thing as 5x cubed minus 5c cubed. And we're trying to solve for c. That's all we care about. We're only trying to solve for c, okay? So these are present on both sides. I can subtract 5x cubed from both sides. Those are going to go away. And if I multiply both sides by a negative, I get 5c cubed equals negative 40. From here, if I divide both sides by 5, I get c cubed equals negative 8. And then if c cubed equals negative 8, that implies directly that c has to be negative 2. If I take the cubed root of both sides, that's what I did there. Cubed root of c cubed is just c. Cubed root of negative 8 is negative 2. So c has to be negative 2 for this problem. Okay, so there's that one. That one is done. Yeah, I mean, these other problems are just a straightforward application of the fundamental theorem, and there's videos on here that I've gone over that. So as I'm looking through these, I've basically already covered, all the concepts in the videos, okay? But I'm still here if you guys have more questions, okay? So please, if you're struggling, let me know, and I'll go over more stuff. And there we go. 7 minutes. That was a pretty good time. Anyway, see you later.